Welcome. In this video we'll develop the derivative rules for all of the other trigonometric functions. We've already started with the sine and cosine and we'll find the rest in terms of those. We start by just reviewing the idea of our other trigonometric functions. Every trigonometric function is defined in terms of the coordinates of the unit circle. So if I start with the unit circle, I've got an angle of theta that I measure from my positive x-axis. And that'll intersect the unit circle at some point, and let's label that xy. The y-coordinate of that point is the sine of the angle, and the x-coordinate of that point is the cosine of the angle. Now if I imagine the triangle formed by bringing the point down to a vertical line, or to a line perpendicular to the x-axis, we get a right triangle with the angle theta. Sine is opposite, cosine is adjacent. And because this is a right triangle, we get the Pythagorean identity for sine and cosine. Sine squared theta plus cosine squared theta equals 1. Well, if I thought about my x and my y coordinates, notice that my angle goes through the point 0, 0. So I could actually calculate the slope of this angle, and this is how we define the tangent. The tangent of an angle is the y-coordinate divided by the x-coordinate, and that's the slope of the line. Because y is sine and the x-coordinate is cosine, we can also define the tangent as the sine of the angle divided by the cosine of the angle. And so this makes the tangent defined as a quotient. All right, if I think about my right triangle with sine and cosine, if I divide the sine by cosine, I can create a similar triangle if I divide all three sides by the cosine. And this gives me the motivation for our next trigonometric function, the secant. So if I take 1 and divide it by the cosine, that's the secant of the angle. And I get a similar right triangle, again with the angle theta. This time one of my legs has a length 1. So the Pythagorean identity for tangent and secant is that the tangent squared plus 1 is always equal to the secant squared. So here we divided our original triangle by cosine on all three sides. If I divide by the sine on all three sides, I get another similar right triangle, and this leads to the cotangent and the cosecant. The cotangent of an angle is the cosine of the angle divided by the sine, and the cosecant is 1 divided by the sine. These right triangles motivate why we group the cosecant and cotangent together, and we group the tangent and the secant together. All right, with these definitions, now that we've defined our trigonometric functions as quotients, we can use our derivative rules to find their derivatives. We start with our elementary derivatives. We know that the sine's derivative is cosine, and the cosine's derivative is negative sine. So we can use the quotient rule or the general power rule to find our derivatives. So for example, the tangent is the quotient of sine over cosine, and the secant is 1 over cosine, which means it's the cosine of x raised to the negative 1 power. We'll do the tangent's derivative first. Using the quotient rule, low-de high minus high-de low over low. Our low function is cosine, our high function is sine, so low-de high gives me cosine times sine's derivative, minus high-de low gives me minus sine times cosine's derivative, all over low, which is cosine squared. So the sine's derivative is the cosine, and the cosine's derivative is negative sine. And negative sine times negative sine is plus sine squared, and notice on the top I have a Pythagorean identity. Cosine squared plus sine squared equals 1. And so my tangent's derivative is 1 over cosine squared, which is the same as secant squared. So the tangent's derivative will be secant squared. Let's now do the secant's derivative. Because we've written it as the power of a cosine, it's the cosine of x raised to the negative 1 power, I get to use the general power rule. U to the negative 1 has a derivative of negative 1u to the negative 2 power times the derivative of u. So I get negative of the cosine raised to the negative 2 power times the cosine's derivative. And the cosine's derivative is negative sine. And so the negatives cancel, and I get positive sine of x over the cosine squared of x. And if I want to think about that in terms of my other trigonometric functions, let's group the denominator into two parts. I get 1 over cosine times sine over cosine, which means the secant's derivative is the secant times the tangent. Okay, I can do the same thing for the cosecant and the cotangent, and I get the following derivatives. Notice that there's a pattern. The derivatives we find for sine, tangent, and secant, they all have a positive sign. It's the cosine, the secant squared, and the secant times the tangent. For each of my three co-functions, the cosine, the cotangent, and the cosecant, they follow the same basic rule as the sine, tangent, and secant, but we introduce a negative sign and we use the corresponding complementary function. So cosine's derivative is negative sine, cotangent's derivative is negative cosecant squared, and the cosecant's derivative is negative cosecant times the cotangent. All right, carry on. I'm sure you'll do great with these derivatives.